All right. So, shall we get started on the warm up? All right. So, it's asking us to calculate the wavelength. Well, they want the wavelength in centimeters of a wave with the frequency is given. So, what equation will you use if you're trying to find the wavelength? C equals, okay, it's not aligned. So let me align it. Very good. C equals lambda nu. All right. C equals lambda nu. All right. C is the speed of light, which is 10 to the 8 meters per second. You're trying to calculate the wavelength, and your frequency is 265 hertz. Is that right? Or it's per second. So you divide both sides by 265, and can someone tell me what did you get as your wavelength for this answer? Can anybody share? 113 times 10 to the 8 meters. They want, this is in centimeters? Yeah. So this right now is in meters. You have to convert it to centimeters. So meters to centimeters, 10 to the 2 centimeters makes a meter. Yes or no? 100 centimeters makes a meter. Yes. I don't know. Somebody provided me the answer. Okay, this 10 to the 6 is the answer in meters. And that becomes 113 times 10 to the 8 in centimeters. Do we get this? Do we all understand this problem? Well, do you want me to do the problem? I can do it. Divided by 265. So 113, 1, 2, 3, 4, 5, 6. That's correct. That's the correct answer in centimeters. Any questions? All right. So the next one, again, is asking for the frequency, which means you use the equation C equals lambda nu again. You have the speed of light equals, the wavelength is given in what units? It's given in nanometers. We would like it in what units before we substitute into this equation. We want it in meters. So your wavelength is 2.967 times 10 to the 9 nanometers. I want to get out of nanometers into meters. Isn't 10 to the 9 nanometers a meter? So can you just get rid of the 10 to the 9? All right. So your wavelength is 2.967 times your frequency. So if you divide your speed of light by 2.967, you will have 1.011. That's 4 sig figs. 1, 2, 3, 4, 5, 6, 7, 8. Is that right? Times 10 to the 8 hertz. Is that right? Are you all getting the same answer that I am? Were you able to do the problem? What is it, Cameron? Okay, so the question is asking us to give it in megahertz. So 10 to the 6 hertz makes a megahertz. Is that right? So this is 1.011 times 10 to the 2 megahertz. Is that right?
Yes.
Are we good? All right. So the last problem, the energy of a certain light is given. Calculate its wavelength in nanometers. Is it visible? So you're trying to calculate the wavelength given energy. Is that right? So will you use the equation E is equal to hc by lambda? Is that right? You can directly get the wavelength if you use this equation. Now, E is given 4.57 times 10 to the negative 19 joules is given. I must have included Planck's constant. By the way, you never memorize Planck's constant. It's always will be given to you, all right? It's 6.6, I think you learned it as 6.3, is that right? Times 10 to the negative 34 joules second, that's Planck's constant, times your speed of light is 10 to the 8 meters per second, divided by your wavelength. Is that right? Your wavelength is your x. Right? So I can switch these two, right? Yeah. My wavelength equals this whole number in the numerator, which is, I'm going to multiply 6.63 to the negative 34 times 3 to the power of 8 is 1.989 times 10 to the negative 25 divided by 4.57 times 10 to the negative 19. Alright? Divided by 4.57 negative 19. And I'm getting my answer as 4.35 times 10 to the negative 7. It will be in what units? It will be in meters. Right now everything is in meters. You have to convert it to nanometers. Alright? So 1 meter is 10 to the 9 nanometers. Alright? This is nothing but times 100. Is that right? So this will be 435 nanometers. If it's 435 nanometers, is it in the visible region of the spectrum? What is the range human beings can see? 400 to 700. Yes, this is in the visible region of the spectrum. Yes, it is in the visible region of the spectrum. Okay? Are we, so the quiz was supposed to be something like this for this class, but I canceled the quiz. Is that right? Yep. Are we good doing such problems? Do we feel comfortable doing these problems? Anybody has any questions on this? Okay, I'm going to save this because I cannot deal with the number of absences that are here.